Welcome to the GibbsCAM video on how to do a live tooling lathe part. This is in the latest version of Gibbs, version 13.0.22. So the first thing we're going to do is go up to File, click on New, and we're going to call it Live Tooling Lathe. And now next we're going to go to File and Import. We're going to import our lathe part for live tooling, and as you can see here, it's going to come in according to how the engineer drew the part. You're not always going to get the origin or the layout exactly the same as you like it, but this is pretty easy to fix. Just click on the solid, modify, 2D rotate. I'm going to rotate this 90 degrees clockwise, and now we have it in position. From here I'm going to go to modify and do shrink wrap, so Gibbs will wrap material around the outer boundaries of our solid model we just brought in. From here I'm going to go to my document control, make sure I'm on the C-axis horizontal lathe, choose our material, and we're going to adjust our stock sizes here. We did a shrink wrap here at 6 inches. We're going to start out with 6 1/4 material, and I'm going to say there's 50 thou to face off on the front of the part. Don't need to really worry about these two unless you have a sub-spindle machine. Mill class I'm going to designate as none, because you can choose just about anything you want here depending on your machine. The shank I'm going to choose 1 inch. You can see the 4 different sizes here. The most popular, of course, is 1 inch shank. This is the square stick holders that fit in your turret. We're going to, of course, program in inches and diameter. Now, you can use auto clearance, but I normally don't, because I like to have it go to the positions I'd like to when I'm turning. So these two positions need to be larger than your stock size and your Z here, because this is where the tool is going to wrap it to before it starts cutting and after it's done cutting to go back to do a tool change. So I'm going to make this 6.350, and this 0.2 was just fine for that. Okay, we're going to close this. Now the next thing we want to do is, of course, get the geometry from our part. So you can do this very easily by clicking on this slice plane, but this time we're going to choose that drop down arrow and click on slice spun body. Clicking on that, you can see Gibbs spun the body as if it was a 2-axis turning lathe, and I'm just going to extract the geometry here because I like to have that instead. You can machine right from this extracted geometry you want from the profiler or not. That's up to you. I'm going to turn this off now, and now I have my geometry there. Of course, I can manipulate my geometry as I need to right here, but this is good right here. Now, one thing I'm probably going to do is rotate this so this keyway is straight up here, because it'll make it easier to program than making a plane to go over here. So we might as well make it as easy as we can. So I'm going to click on the solid model, and then I'm going to rotate my part here. Now, this came in with the origin, the slice plane right through the corner of that hex on there. So I know with hex is 6 sides, so this will be 30 degrees. So I'm going to click on that, the solid, go to modify, 2D rotate, put 30 degrees in there, counterclockwise, make sure you're on the right plane, which needs to be the XY plane. Click on do it, and now I have my part in the right origin that I like when I'm machining the keyway. From here I'm going to do a quick little measurement of the keyway. Of course, normally you'd have a print anyway so you can see this, but I'm just going to go to plugins over here and click on solid inquiry, face selection on, select that radius there, and you can see it's a 1/4 inch radius there, so 1/2 inch wide slot. So everything else is pretty equal, this won't matter here because my my turning tool will easily cut that. But I can see I need to use something less than a 1/2 inch to cut this keyway. So let's make some tools with this. Open up my tool palette. First tool I'm going to make is turning tool, 80-degree diamond, 32nd tool nose radius, inscribed IC, 1/2 inch. And it's sitting, of course, you can see the different orientations. It's going to be sitting in the turret this direction. Click this drop down arrow and click on tool holder. And you can see there's the tool right there. Okay. It's going to be sitting in position number 1. So offset number 1 should match. You don't need tool ID for just a live tooling lathe. Don't worry about notch ramp. That's more for ceramic inserts. But you can see the insert is facing up and the spindle direction is reversed. So this would be an M4. Normally I like the insert on the back side, so I'm going to click on forward and you can see the insert's going to be on the back side there. You can name your tool if you'd like. I'm just going to have this as a carbide insert coated. Of course, that's going to be your most popular tool there. Okay, that tool is done. Now I need to, that's going to use it for facing and roughing the OD. Now I need to come back and take a finish pass. So the second tool I'm going to make is going to be a 55-degree. We're going to make that a 64th tool nose radius. Again, 1/2 inch IC. Tool holder here, and you can see the different tool holders by selecting this button here, this slider right here. This isn't a real popular tool, 17.5 face relief. These are standard ANSI holders, that's why you see this here. I'm going to click down one and you can see this 5-degree face relief. That is probably your most popular orientation for the tool. Of course, it's sitting in the turret this direction. And offset's going to be number 2. So that's going to be our finish tool. Now I need to make a couple of live tools to cut the hex and cut the slot here. So my third tool is going to be a rough milling tool. It's sitting in the turret this direction, facing our spindle. And this is going to be a 1/2 inch spindle tool, 1.5 inch flute length. I'm just going to say 3 inch overall, and sticking out of the tool holder 2 inches. And of course, tool length offset here is going to be 3 and cutter comp 3 as well. And you can designate a tool holder if you want, but I'm just going to leave this blank for right now. So that's going to be our, I'll just call this our rough tool. I'm going to make another one exactly the same, but this is going to be a finish tool, and this is going to be 5 flute. We're going to change this back over here to 4 flute. So this is going to be a 5 flute finish tool, same dimensions. I'm going to call this finish tool. Now I need 2 tools for the keyway. Actually, we'll just probably keep this as 1 tool, and then we'll make the drills here. So the next tool is going to be a 3/8 end mill, 1 inch of flutes, 2 inches overall, sticking out 1 inch from our tool holder, and probably a 4 flute there as well. And of course, it's sitting in the turret this direction. That's coming from the X direction to cut our slots there. So I'm going to call this rough finish. Now the last tools we need are the ones for the holes here. So I'm going to extract the geometry off here so I can do that as well. But first I'm going to put that in its own separate work group or layer, you can call it. This is our work group section. I'm just going to rename this to turning. We'll make a new one. I'll call this milling. You can make as many as you'd like to separate them how you would like to. So this is going to be our turning. This is going to be our milling. So I'll keep it on milling here. And I'll click this face right here. and I can do extract the edges. That'll give me the holes. First of all, I want to make sure I'm in my right coordinate system there as well. There's the holes there. If I'd like to dimension that, I could if I want to dimension a hole. They're 1/2 inch holes. So I want to spot drill and then chamfer those holes and then drill them. So I'm going to create another tool. I'm going to make a spot drill sitting in this direction. It's going to be a 1/2 inch and 1 inch overall, 1 inch flute length. This is pretty long, so I'm going to make it 3 inches overall and 2 inches out of the holder there. And 90 degrees will be our angle there, or I can change that to 82 or whatever we'd like for a spot drill. Next, number 7 is going to be our drill. It's going to be a 1/2 inch drill this time. Sitting in the same orientation, this time we're going to have 2 inches of flute length and probably 4 inches overall, 3 inches out of the spindle there. And this one I'm going to do 135 angle drill. And we'll stop at this point and get up to this point, and then if we have time we'll put a chamfer on these holes here. So let's go back to our turning menu first and go back to our ZX plane, and I'm just going to go to top view on here. Then I'm going to open up our cam palette, double click here, go to our turning menu here, and the first thing I'm going to do is just face the front of this part off. I'm just going to take it in a single pass, so I'm going to do contour with that tool. I'm going to go front face, I'm going to wrap it to 0.2 when we're done. I'm going to do a 90-degree line when it comes off the part, backs off to go home. CSS stands for constant surface feed. I'm going to say max RPM 1500. Surface feet per minute 300 is a good place to start for steel, and 12 thou feed rate. No cutter comp, flood on, everything else here is good. I'm going to leave 3 thou to face off for the finish pass. I'm going to click on the front face, drag my start marker larger than my stock, click the dark blue arrow down, which means we're going to go from the top down. Take the black round one, put it on the X0, Z0 point, and click on do it. And there's my first tool path there to face off the part. Now I'm still going to use the same tool here. I just want to change the process to a roughing process. Same tool. I'm going to change to an OD now. Going to wrap it to 6.35 before we cut. 6.35 when we're done. 6 1/4 is my material. I'm going to change that to 1/8 of an inch. XR means radially, so I'm going to cut 1/8 of an inch per side on here. Again, constant surface feet per minute. G96, 1500, 12 thou. Good place to start. And I'm going to leave 10 thou on the stock, which will leave 20 thou total because this is XR, and 3 thou on the Z. Flood on, prefer CAN. This is going to give you your G71 CAN cycle for most machines. Close that. I'm going to click on this little chamfer here. You can either drag this marker off, or you can right click and say move it off the part by 100 thou, and it will update that if you'd like. We're going to unzoom it. I'm going to hold down the Alt-Shift key, click on this last surface here, and I'm going to actually go right to the end there. Click on do it, and you can see you have your tool path there. Now we're going to do a cut part render here just to see where we are on the rendering. I'm going to slow this down a bit, and we're going to click on play. I want to show the tool holder, we can do that as well. We'll speed it up a little bit. So far looks good. Okay, our next section is going to be to take a finish pass along here. So I'm going to clear this, double click here, go to my turning, do a straight contour here with our 55-degree diamond. Again, OD. This time I don't want to wrap it at 6.35 up here and feed all the way down, so I'm going to wrap it to 0. And when I get done cutting, 6.35, which is fine. I'm going to change this to 400 surface feet, and we're going to change our feed rate to 6 thou. Still don't need cutter comp. I'm going to zero out the Z. Everything else here looks good. Again, I'm going to click on the front face because I want to face it off. I'm going to start now right there at X0, Z0. Again, Control Shift, end of our part. Click on Do It. Now we have a finish pass. We could watch that as well. Sorry. Let's take a finish pass on here. There's our finish pass. Alright, now we're ready to start doing some live tooling stuff. So for now, rotate our part a little bit. I'm going to go to our work group number 2, milling. And I need to change my plane because I'm not doing turning anymore, so I'm going to go to my coordinate system and click on the XY plane. That means the tool is going to come from the face. I'm going to clear this out. Now we're going to the milling section here, and I'm going to click on contour, and the first tool I'm going to do is a rough end mill. Actually, we'll stay with the rough end mill. That'll be just fine. And first of all, before we fill any blanks out, we want to make sure we're on the right plane. So XY plane. Input my RPM and feed rate. I could choose here and input it, have it automatically input the feeds and speeds, or I can choose what I want it to do. I'm going to wrap it to 0.1 from my part. My material, I face it off so it's 0, and here I want to go right up to the shoulder there. So an easy way to do that in Gibbs is just highlight this box, hold down the Alt key, click on that face, and you can see it inputs the value there already, which is of course -1 inch. I'm going to do a little bit of an entry and exit, arc in, arc off, stock. I'm going to leave about 10 thou to finish on there. I'm not going to do any Z ramp. No round corners, and I am going to, well, actually on the roughing I'm going to leave cutter comp off, okay, and everything else should look good. Now there's two ways to cut this. If you have enough travel in your machine and you have a y-axis, you can lock the spindle and go around it using X and Y. If you do not have a y-axis, or you prefer to do polar and cylindrical, you can choose that, and the X will only move and the C will rotate. You can see we have that choice here, position or polar and cylindrical. We'll just choose position for now because we have enough travel. So for here I'm going to grab my profiler, and I'm just going to drag it about halfway through the part there. Looks pretty good. I'm going to start on this line, and about halfway over, we'll probably be pretty good. We'll start right there. I'm going to click on Do It, and you can see there's my tool path going around it. Now while I'm here, I might as well do the finish pass as well, so I'm going to put another tile underneath this contour with my finish end mill. Same parameters here, except I'm not going to leave any stock. Zero that out, and I might change the RPM to the feed rate to 1520, and I'll click on redo, and you can see if I zoom this up, you have two tool paths here, the rough and the finish, and we also have two more operations over here. So let's do a cut part render to see where we left off here. slow this down a little bit. So there's our rough. Come back, and here's our finished pass. So far, so good. Now let's do our keyway here. So I'm going to turn off profiler. This time I need to go to the YZ plane. As you can see, the plane is right here. Tools always come from perpendicular to the plane. And here I'm going to turn off my cam for just a moment, and I'm going to extract the geometry off this keyway here. Now, of course, there's a couple ways you could do that as well. You could drag the profiler up through there, which would give you that. Or another easy way to do it, just select the face there, and I'm going to extract the geometry and do that. Or you could just select this face and click on do it, and Gibbs would cut this anyway. But sometimes I like to use the geometry there. Open up our cam palette. Let's clear these out. Start a new process. This is going to be, of course, milling. Do a contour with our 3/8 end mill. Again, make sure you're on the right coordinate system, YZ plane, which is perfect. 1500, 2020 will be just fine. This time I'm going to rapid to this surface right here, or close to it anyway. It's 1.5 inches. I'm going to say 1.6 you could rapid to. This will be 1.5 inches is where the material is we're cutting. Now this time I'm going to hold down the Alt key, click on the bottom of this keyway, and you can see that's 1.25 inches. Then when I'm done cutting, 1.6 again. Our feeds and speeds are fine. I don't want to do that big of an entry and exit, so I'm going to say 50 thou. Be just fine. Stock, I'm going to leave again 10 thou on the stock. Not going to use cutter comp on here. That looks good. Now while we're here, I might as well do multiple process programming, so I just can select this one time. So I'm going to put another contour on here with the same tool again. This time, I'm not going to leave any stock. Maybe on the previous one, I'll open that back up again and leave about 5 thou on the floor. Then we'll let the finished one take the floor and the sides as well. I'm going to go to home view. This is going to flip it up oriented to our screen. I'm going to click on the side here. I want to climb mill, so I'm going to cut this direction, dark blue arrow, and I want to start off the part just a little bit. And again, Control Shift, select the opposite side over to there, and click on do it. And now I have my tool path for the keyway. Now when I render, you're going to see we're just doing one keyway here and finish. But I want to do 3 keyways because there's 3 keyways on the part there. So I'm just going to go open my process I just did on the rotate. I'm going to say do it 2 more times at 120 degrees. Open up my second process, which is the finish one, and do the same thing, 2 at 120. I'm going to click on redo. Now you can see it did all 3 there. So if I was to render now, second one, third one. Okay, so let's finish the holes now. Turn off my rendering. I'm going to go to the XY plane, clear these out, put in my first process, which is going to be holes, along with my spot drill. Make sure I'm on the right plane here. I'm going to rapid. This is where our material is, so I'm going to hold down the Alt key, click on this face. You can see it's negative 4.5. So I'm going to rapid to -4 inch. And when I'm done, I'm going to go to -4 inch. So it's going to go around each of the holes first before, and then finally retract and go home. Now here I want to make sure the spot drill chamfer is a big enough hole before I drill. The holes are 1/2 inch and my spot drill's a 1/2 inch, so I'm going to say you can cut a 0.3 diameter hole there and it'll calculate the depth for us. You can update our RPM and feed rate. We'll just feed in and wrap it out. And there's a couple ways to do this as well. You can select each hole separately, or you can say polar and cylindrical, especially if you don't have enough travel on your y-axis to go underneath, which is the case on probably here because it's a pretty big part. So we have 1, 2, 3, 4, 5, 6 holes, so I'm going to need it to do it 5 more times. I'm going to type 360 divided by 6, and that's going to give me my angle, 60 degrees. Close that, select this hole, click on do it, and you can see there it is going around our part there. So the next thing I want to do is, of course, drill it. And we can either clear this or put it underneath. This time I'm going to just clear it and put another drill here with the drill process with the drill. And again, everything there is filled in correctly except for the depth. I want to make sure the drill gets clear through our part, so I'm going to rotate my part so I can see the back side there. Highlight this box which points to the corner of the drill. Hold down the Alt key, click on the back face. You can see it's basically -3 inches. I want to go a little bit past, so I'm going to go -3.1 to make sure we don't leave a little burr on the back there. I'm going to update RPM and feed. Now that's pretty fast. I'm going to go 3000. You can always change the material database if you want to change your feed rates there, surface feet per minute, based on your material. So you can always do that and keep that permanently. Okay, we're going to do the same thing, 5 holes every 60 degrees. Now between holes I'm going to go to the R level instead. That way it'll keep it at the -4 rather than coming out before it rotates. Again, we're going to click on the hole there. I'm going to start there, click on do it. Now we should have, make sure I'm on the right orientation there first, sorry, XY plane. Okay, and we'll update that, and we should have our depth here. Sorry, I need to update that. That's what happens if you're not on the right plane when you put in these numbers. So it's -6 inches, so I'm going to go -6.1. Okay. I'm going to update these as well. The rest of that looks pretty good. Okay. So that's through our part. We'll close this now. Then we'll go to our cut part rendering. We'll start out from the beginning. Speed this up a little bit till we get to the milling portion. Finish slots, spot drill, drill the holes, and our part is finished. Now if we want to see what it's going to actually look like when it's running on the machine, we can change this point of view lock to actually what the machine will be doing, how we programmed it. Right now the part stays still and the tools move around the part, but we can change that. Just by clicking on this point of view. Instead of point of view on fixed part, we're changing that to machine. Let's render again. Start turning. And let me slow it down a little bit. This isn't rotating the Z-axis because we told it to just use X and Y. But here we need to rotate the part. There's the rough, then finish. Then of course our drilling, our spot drilling. And of course drilling. And we have our part finished with live tooling lathes. Hope you enjoyed this video.